In this video, we are going to see how to classify the points of an indoor point cloud automatically and manually. First of all, we are going to use the automatic classification tool using artificial intelligence. As an example, our work area will be a specific area of the point cloud which we select and filter using the application's editing tools. For the automatic classification, we will use a model trained specifically for the classification of indoor points with categories such as floor, ceiling, walls, windows, doors, chairs and tables. That's why we define in our project those same categories using the category properties dialog. This dialog allows us to change both the names of some categories and their associated color. We can see that initially the point cloud is not classified, so it is not possible to represent it by categories. In the automatic classification by artificial intelligence dialog, we establish both the model to be used, in this case a model for interior classification, and the mapping to be made between the categories that this tool is capable of discriminating and the categories defined in the project. In the latest version of the application, the categories of both models are predefined to make the work easier. After the automatic classification process, we can now represent the point cloud by categories. By clicking on the corresponding button in the menu ribbon, we can see how the points have been classified into the different categories that the model recognizes. There are also points that could not be classified. To check the classification of the interior points of the point cloud, we deactivate the ceiling category. The chairs and tables inside the point cloud are visible in different shades of green. The windows are also visible in light blue. The representation legend by category located in the project panel allows us to consult which category represents each color. When we undo the filtering of points, we can see that the rest of the points in the point cloud have not been classified, remaining in the unclassified category. We now focus on another unclassified area of the point cloud to show how to do manual classification. Using the selection by elevation tool, we can manually select the ceilings present in this area, setting the lower and upper dimensions and providing a height band. With the selection by estimated plane tool, we can do the same thing in an easy, local and controlled way. Just click with the mouse on flat areas corresponding to the ceiling in this case. Once the selection of points is done, we associate the ceiling category previously defined in our project using the controls available in the application's menu ribbon. In the same way, we use this tool for the selection of points on the floor, since in general they also correspond to areas of adjacent and coplanar points. We assign the newly selected points the category floor. In contrast to the selection by elevation tool, the selection by estimated plane tool is also very useful for the selection of points on walls, which also correspond to flat areas. We assign the newly selected points to the category wall. Using the category properties dialog, we hide the ceiling and floor categories. This will allow us to work with the interior points of the point cloud. Next, we use the selection by vicinity tool. Once we have set the selection radius and vicinity distance parameters, we can select groups of neighboring points by clicking with the mouse on a single point in each group. The points thus selected are also assigned a category, as we saw earlier. After classifying all the points in the point cloud using the various selection and classification tools mentioned above, we get the results shown. We deactivate all the categories except for floor and walls to easily analyze the structure of the building.